In this video, me and my group mates will talk about renewable energy, which is solar panel. First, I will explain about solar panel and its significance. A panel that is designed to absorb sunlight as a source of energy to generate electricity by using photovoltaic PV cells. PV cells are made of materials that will produce excited electrons when it's exposed to the light. The electrons will flow through the circuit to produce direct current, DC electricity that can be used to power various devices or to be stored in batteries. Solar panels does not contribute carbon emission when producing electricity. So, solar panels become one of the alternatives to reduce the pressure on our atmosphere from emission of greenhouse gases. Nowadays, solar panels are widely used to address multiple global challenges because they are from renewable sources of energy. Solar panels can significantly reduce greenhouse gas and carbon emission. It also can be beneficial for the environment and economy in the future.
What are solar panels made of? Alright, the main component of a solar panel is the photovoltaic PV cell, which is responsible for converting sunlight into electricity. PV cells comprise a semiconductor material, usually silicon, with unique electrical properties that make it ideal. Silicon is a highly abundant and versatile material widely used in electronics and other industries. PV cells typically consist of a thin water of silicon coated with a layer of phosphorus and boron to create a positive and negative charge, respectively. Another key material in solar panel construction is the substrate, which provides a stable base for the PV cells to sit on. The substrate is usually made of glass, which allows the solar panel to harness as much sunlight as possible while protecting the delicate PV cells from the elements. Glass must be specially treated and coated to resist scratches and minimize reflection, both of which can reduce the panel's efficiency. The third major component of a solar panel is the frame, which provides support and protection for the PV cells and substrate. The frame is typically made of aluminium or a lightweight, durable metal that can withstand the weight of the panel and any weather conditions it may encounter. The frame also helps to keep the panel in the correct position for optimal sunlight exposure. Solar panels are highly relevant to scientific instrumentation, especially in remote sensing, space missions, field research, and renewable energy studies. Here's how they connect. So, solar panels are highly relevant to scientific instrumentation because they provide a clean, renewable power source for operating scientific equipment, especially in remote or off-grid locations. Instruments such as weather stations, air quality monitors, seismographs, and ocean buoys often rely on solar energy to function continuously without human intervention. Next, in space exploration, solar panels are essential for powering satellites, space telescopes, and scientific instruments onboard spacecraft, enabling them to collect valuable data on Earth and the universe. In addition, solar panels themselves are often studied using scientific instruments to monitor their efficiency, voltage output, temperature, and long-term performance. Researchers use tools like multimeters, data loggers, and oscilloscopes to analyze how solar panels convert sunlight into electricity and how different conditions affect their operation. In educational settings, solar panels are also used in experiments to teach concepts related to energy conversion, electronics, and environmental science. In overall, solar panels play a dual role in scientific instrumentation. They act as both a reliable power source and a subject of study for advancing renewable energy technologies.
Detailed exploration of solar panel. As we know, solar panels helps convert sunlight into electricity, and the material inside them is what makes this possible. So let's explore the four main types of solar cells used in the industry today. The first and the most widely used type is the crystalline silicon solar cell, which makes up about 90 to 95% of the global market. These cells are made from highly purified silicon and are known for their durability, high efficiency, and long lifespan of 25 to 30 years. Crystalline silicon is divided into two types, which is monocrystalline and polycrystalline. Monocrystalline cells are made from a single crystal of silicon, giving them a smooth black appearance. They have the highest efficiency, usually between 18 to 23%, and perform well even in low light or high temperatures. However, they are also the most expensive due to the complex manufacturing process. Next is polycrystalline, or known as multicrystalline cells. These are made by melting multiple silicon fragments together. The surface looks blue and speckled due to the different crystal orientation. They are more affordable and easier to produce, but slightly less efficient, around 15 to 18%, and also less effective in height heat. Lastly, we have thin film solar cells, which are quite different from silicon-based cells. These are made by depositing thin layers of photovoltaic materials like cadmium telluride or CIGS onto glass, plastic, or metal. They are lightweight, flexible, and cheaper to produce. However, they have lower efficiency, typically around 10 to 13%, and require more surface area for the same power output.
First example is residential and commercial installation. For example, many homeowners install rooftop solar panels to reduce electricity bills and carbon footprints. For example, a family in California installed a 5 kilowatt system, achieving a 70% reduction in electricity costs. Another that is commercial building and warehouse, such a large warehouse in Texas with a 500 kilowatt system, use solar panels to power operation and lower operational expenses. Example number 2 is large-scale infrastructure. For example, is airports. Kochi International Airport in India is the world's first fully solar-powered airport. Its solar plants generate more electricity than the airport consumes, with surplus energy fed into the grid. The airport also uses solar carports and floating solar panels, and developing a green hydrogen plant powered by solar energy. Example number 3 is off-grid and humanitarian projects. Off-grid solar system in places like Kenya provide electricity to homes previously without power, improving living standards and economic opportunities. In the Philippines, solar power emergency shelters ensure reliable power during disasters, enhancing resilience and emergency response. Solar panels power clinics in Uganda, ensuring reliable electricity for medical equipment and improving healthcare delivery. For example number 4, solar also used for innovative and niche use. For example, solar power internet cafes. Projects like Zubabox in Kenya use solar panels to power internet access in remote locations. Another that, the Seoul Cinema in South Wales is a fully solar powered mobile movie theatre. And solar panels power conservation centers such as those in Kenya, supporting environmental and wildlife protection efforts.
Next, I will talk about potential benefits and challenges of solar panel. One of the benefits of solar panels is decreases greenhouse gas emission. Solar panel is eco-friendly, clean, and uses sunlight energy to generate electricity. Solar panel does not produce any carbon emission or air pollution because it didn't use any fossil fuels. In addition, switching to solar panel has the same emissions reduction effect as planting 125 trees every year or eliminating annual production of 8,308 pounds of coal. Next, reduces Respiratory and cardiovascular health issues are also one of the benefits of solar panel. Solar panels don't emit pollutants when producing power and electricity. One residential solar panel system can eliminate 3 to 4 tons of carbon emissions each year and equals to more than 100 trees planted annually. It also can reduce the incidence of respiratory and cardiovascular disorders and chronic bronchitis. Other than that, reduced electricity costs are also one of the benefits of solar panel. Since solar panels use the sun's energy to generate electricity, the consumers will not be paying the energy we generate through the solar panels. Consumers can save a considerable amount of money by not paying high monthly power bills by switching to solar panels. Lastly, low maintenance costs. Solar panels does not require a lot of maintenance. Residential solar panels usually require cleaning a couple of times a year. Solar panels need to be cleaned if they have collected any dust or debris. Consumers don't need to spend anything extra for solar panels system to keep it working at optimum. Next, I will talk about some of potential challenges of solar panels. One of the challenges is climate variability or changes. Weather changes such as cloudy and seasons of the year can affect the amount of solar energy that can be generated. Regions with high levels of rain or snow can make the solar panels does not work effectively. It is because the climate change will block the sunlight to the solar panels to generate electricity to the houses. Next, energy storage are also one of the challenges of solar panel. Solar panels generate energy during the day, and of course, not all of the energy will be used at the time. But it becomes one of the challenges because of the energy that can be stored and used when it is rainy or cloudy days. To increase the energy storage, consumers need to add batteries, which will cost more money to install and for maintenance. Other than that, manufacturing of solar panels will harm the environment are one of the challenges of solar panels. Solar panels produce clean and renewable energy, but the manufacturing of solar panels may result in fossil fuels being burned and plastic waste. The manufacturers are not eco-friendly and will create a considerable amount of greenhouse gases. Lastly, disposal of old solar panels can harm the environment. Solar panels contain some of the environmentally harmful substances, which can produce some harmful chemicals during disposal process. It can harm the local areas and our Earth's atmosphere.
Hi everyone, my name is Saidati. So today I will continue to explain about the future development and innovation in solar panel technology. So there are four types of solar panel that I will be focusing on, which are perovskite solar cell, bifacial solar panel, floating solar panel, and lastly flexible solar panel. Our first point is perovskite solar cells. Perovskite solar cells are a type of thin film solar cell that use a perovskite layer to absorb light. When light is absorbed, it creates positive and negative charges that move to opposite sides. A layer called the Hole transfer layer or HTL helps extract the positive charges efficiently. Its active layer is made from a hybrid organic-inorganic material, typically containing lead or tin halides, which functions as the light-absorbing, electricity-generating layer. Some of key advantages of perovskite solar cells is high applicability. Perovskite solar cells have a conversion efficiency of 25.7%, rivaling traditional silicon solar cells with an efficiency rating of 20 to 22%. Secondly, its low-cost manufacturing. According to the University of Michigan, perovskite solar cells could be 2 to 4 times cheaper than traditional solar panels. And lastly, is its lightweight. Perovskite is more lightweight than silicon wafers, meaning that it can be potentially applied to different surfaces such as cars and infrastructure. Next, we have bifacial solar panel. Bifacial solar panels are designed to generate electricity from both sides by responding sunlight both on the front and rear panels. The panels are able to capture sunlight from both sides, potentially delivering greater efficiency and taking up less space. Some key advantages of bifacial solar panel is it increases energy production. Bifacial panels can generate 5 to 30% more power than traditional panels by capturing sunlight from both front and back sides. Secondly, it better low light performance. These panels perform well by capturing reflected and diffused light, allowing longer daily operation and better efficiency in low sunlight conditions. And lastly, is durability. Bifacial panels are frameless and protected on both sides by tempered glass, making them more durable and resistant to weather, UV rays, heat, and strong winds. The third one is floating solar panel. Floating solar panels are photovoltaic power systems that are installed on a body of water, such as quarry lakes, reservoirs, and ponds, where they convert sunlight into energy. The key advantages of this system is space efficiency. Floating solar panels optimize space by utilizing water surfaces for energy generation. This method offers up to 15% enhanced efficiency compared to traditional ground-mounted systems. Next is reduce algae growth. Floating solar panels help limit algae growth in water bodies by reducing the amount of sunlight that reaches the water surface. By blocking excess light, they create a more stable aquatic environment and support a healthier ecosystem. And the last one is water resource management. Floating solar panels is water conservation. By covering the surface of water bodies, they help minimize evaporation, protecting vital water supplies for farming, drinking, and industry. Lastly, flexible solar panel. Flexible solar panels are made with solar cells that are over 300 times smaller than that of traditional solar panels, making them much lighter and more malleable. Flexible solar panels still don't have the durability, efficiency, and power output to replace traditional solar panel as a home solar solution. The key advantages of this system is portable. The main advantage of flexible solar panel is their portability. They are lightweight and easy to carry, making them ideal for use on boats, RVs, or during outdoor activities. Next is easy installation. Flexible solar panels can be easily installed using adhesive like Velcro tape or magnets. This simple setup makes them a popular option for users who want portable and hassle-free solar solution. And last one is wide range of applications. Flexible solar panels can be adapted to suit a range of different installations as they can be shaped to suit the surface. They are a great choice for caravans and camper vans.
Conclusion: solar energy, especially from solar panels, is a key way to make clean energy and help the planet by cutting down pollution. It works well with scientific tools to check and improve how energy is made, like in homes and big solar farms. These tools help measure how much power is produced and make sure everything runs smoothly. Solar panels save money over time and help the environment by reducing the need for dirty fuels, but they can be expensive to set up at first and don't work as well when it's cloudy and rainy. In the future, better technology and better ways to store energy will make solar power even more useful and reliable. For example, new materials might make panels cheaper and bigger batteries could save more power for when the sun is not shining. In short, using solar panels is a simple and important step for a greener, healthier world, and is something we can all support as we learn more about it.